Hello everyone, I am Dr. Tanmoy. Welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. In this reaction, the alkyl halide can't be. So this is, I have asked which Rx can't be used here for this reaction. 4 options are provided. I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now look at the nature. Question is about the nature of alkyl halide. It could be used for this Friedel-Crafts alkylation. By the way, all are alkyl group, that's why alkylation. Now, for that purpose, we should know the general mechanism for Friedel-Crafts alkylation. They'll understand. So, if you take benzene react with Rx in presence of catalyst like anhydrous AlCl3, this R group replaces one hydrogen, produces this R attached, means substitution. Obviously aromatic, it is example of aromatic electrophilic substitution. Along with that HX is produced. This is the overall reaction. Now how the electrophile is produced? Actually here the electrophile is R plus. So how this R plus is produced? For that purpose this Rx reacts with AlCl3. Now if you look at this AlCl3 molecule, it reacts with this halogen. Why? Because AlCl3 is actually a covalent molecule. So if you look at 3 bonds, so total 2 electron pair, 2 electron pair, 2 electron pair for each bond. So these aluminium has 6 electron in its outermost orbital, or it is actually sextet, means incomplete octet. So what it can do? It can act as Lewis acid, and it can coordinate with any molecule having extra electron or lone pair which could be donated. Here halogen has 3 lone pair, so one of them could be donated to this aluminium such that aluminium had 8 electron, means octet field, and obviously R will have a formal positive charge. So in this case what does it produce? Rx. So these lone pair actually donated to this aluminium chloride. Now since aluminium got one negative, means electron pair, so it will have a formal negative charge, and since X have given its electron density, it will have a formal positive charge. So it results in this. Now if you look at X, it's a electronegative atom, halogen, so here it's carrying a formal positive charge, so not stable. That's why this bond breaks. It produces this R plus. This is actually the electrophile cation. Now what about the X? This X obviously attached to AlCl3 such that the aluminium could have octet fill-up structure. Now this R obviously reacts with this benzene, means this pi electron cloud of benzene attacks this electron deficient alkyl cation and resulted in this sigma complex where R, and this is the hydrogen. By the way, previously there was a hydrogen here, and since this benzene attacked this positive charge, so neutral molecule benzene plus cationic species R, so overall a positive charge species. Now if you look at benzene was previously a aromatic molecule, and in sigma complex this aromaticity is lost. So aromaticity means it's a deslocalization, means stability. So because of this reaction stability is lost. So that's why molecule prefers to gain the stability. How? By releasing this H plus. So what is the driving force for this H plus removal? Is actually aromaticity gaining. So you may understand aromaticity gaining means stability gaining. So that is the driving force for this reaction. Okay, now obviously this H plus from here, and previously X minus was attached to AlCl3. By the way, it is not that much stable also, so it will come out as HX. So again this AlCl3 will be released, again it will react with another molecule of Rx. So in this way reaction will continue until all Rx are consumed. So this way reaction goes on and aromatic electrophilic substitution takes place. Now here one thing we understand that, okay, we need to prepare alkyl cation. So in which case alkyl cation preparation difficult, or if you look at the stability of alkyl cation, so that is actually the issue. So you can understand these, in this case this is the allyl cation, and we know allyl cations are resonance stabilized, like this double bond will come here. So this is the double bond, positive charge will go there, means this positive charge is delocalized, means stabilized, so it will be produced easily. So okay, it can participate in this reaction. Now if you look at option D, it is benzylic, student. If this Cl goes, what is remaining? This is benzyl cation. By the way, benzyl cation is also resonance stabilized. How? So it can, this positive charge could be delocalized inside the ring. I am drawing only one canonical form, many other canonical form possible, but I suggest you please try by yourself. I am not drawing. So what do I mean? This positive charge is delocalized all over this ring, consequently it is stabilized. Fine. So these will produce, these will participate in this reaction. Now the next option, if you look at, this is isopropyl chloride. Okay, so it can also participate, it will produce this isopropyl cation. It's a secondary cation, moderately stable, because if you look at 2 CH3 group attached, so you can expect that, sir, 2 plus I effect possible, point number 1, and 6 hyperconjugation possible, which both factors are actually responsible for the stabilization of the positive charge. So they will take place, but the problem will be for option B. So why it is problematic? Because this chlorine has 3 lone pairs. We know halogen, group 17 element 3. So it can do this resonance. So consequently, it can have a partial double bond character here. You can understand. So because of this partial double bond character, you can say the CCl bond is stronger. Stronger means difficult to break. Obviously, partial double bond character, you can say also it is relatively more stable. So that is the reason, because of this partial double bond character or partial double bond nature, these vinyl chloride, by this molecule name is vinyl chloride, these vinyl chloride cannot undergo Friedel-Crafts alkylation reaction. So here, which in this reaction the alkyl halide can't be, means which alkyl halide cannot be used, that is option B. So this is the right answer. Now if this question appears in your exam, how can you solve? For that purpose, you need to understand what is asked here. They are asking that which case the electrophile R plus could be generated very efficiently, such that this Friedel-Crafts alkylation, means aromatic electrophilic substitution, can take place smoothly. In this case, R plus generation is actually dependent on the stability of the cation. So in your mind, you need to think, okay, positive charge here, positive charge here, positive charge here, positive charge here, where the positive charge is minimum stable. Obviously that will not react. And if you look at here, in this case the positive charge is least stable. Why? Because this positive charge in sp2 hybridized orbital, no extra factor for stabilization present. For example, here resonance plus R possible, here also plus R possible, here plus I and hyperconjugation possible, but here no such kind of effect. Not only that, sp2 carbocations are relatively less stable, so that's also another factor. So this will be the answer. You should remember these information such that you can quickly tick this option. This question is not a very tough question, but you need to remember this information. So this is the overall discussion. I believe this very may be useful. Thanks for watching. By the way, if you have any doubt about the logo of my channel, please read this part. I guess your doubt will be clear. So see you in my next video. Bye bye.